All right, in the last video, we started talking about electron configurations. We talked about that order that they fill from lowest to highest, and I said, please don't memorize that order because it's all on the periodic table. So I'm gonna draw a little sort of diagram of how to think about using the periodic table. There is a lot of information packed into this, okay? So here's my rough interpretation of a periodic table. Kind of freehand in this. 1, 2, 3. Okay, you'll note the main difference between my periodic table and, well, between my periodic table and this periodic table is I moved helium over here. Helium is put over here because they want to have it in the same column as the noble gases, but for every other purpose, it needs to be here. Okay, so helium lives here as far as I'm concerned. So I'm going to label some stuff, and it kind of sounds like prison. So this tall 2-column wide thing is the S block. I've never been to prison, but I'm assuming labeling blocks by letters is not an uncommon concept. This is the P block. The transition metals are the D block. We will see repeatedly that anytime there is a rule, the D block screws it up, and that's fine. And then down here, I guess, are the mass murderers, because they're all isolated, are the F block. Okay, so the way this works is you'll note we said that S orbitals can hold up to 2, P orbitals can hold up to 6, Ds can hold up to 10, Fs can hold up to 14. You'll notice that the S block is 2 across, the P block is 1, 2, 3, 4, 5, 6 across, the D block is 10 across, and the F block is 14. Great, it actually works out really nicely. All those numbers are built into the periodic table. You don't have to memorize them. There are also numbers running down the side over here. Let's see if I can try to space these out evenly. Okay, these are your N values. Okay, and for the S in the P block, these numbers are correct. For the D block, the numbering is off by 1. So even though the D block starts in the 4th row, this is 4S, and then this would be 3D. The numbering is off by 1. So this is 3D, oops, 4D, 5D, and 6D. The F block is even more confusing. If you look at this, this goes 55, 56, 57, 72. Basically, there's a big gap there. This entire top row of the F block actually fits in right there. It's actually in the 5th row, or sorry, 6th row. But this is 4F and 5F. God, I wrote a D, sorry, 5F. And this goes there, that goes there. Okay, so now if we had an atom, like at the very end of the last video we did aluminum, let's do aluminum again. And I'm just going to do the electron configurations. It does work for orbital diagrams, but I'm just going to do the electron configurations. So aluminum is element 13. So what we do is we start at the beginning. We're assuming helium is here. So this is 1. This is the S block. So S, 1S, 1, 2. This move over there, so down to 2S, 1, 2. 2P, 1, 2, 3, 4, 5, 6. 3S, 1, 2. 3P, 1. Which is the answer we had last time. So 1S2, 2S2, 2P6, 3S2, and then it's the first one in that block, so 3P1. Okay, so you can actually just use the periodic table to do all of this. Okay, so you'll also notice that this is taking forever. So I'm also going to introduce one more concept while we're talking about the periodic table. I'm going to talk about noble gas abbreviations. I encourage you to use these for pretty much everything. It actually makes life significantly easier. Okay, noble gases are really, really stable. So they're very stable. and we kind of use them as stopping points along the way. So if you're going 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, 3d10, 4p, whatever, okay? We're gonna use these as like landmarks along the way to keep track of where we're at, okay? We use them as like stopping points. Okay, so if we had something like aluminum, as we're going along here, 1s2, 2s2, 2p6, and we hit neon. That's the noble gas that was right before the first, if you count it backwards, it's the first noble gas after counting down from aluminum, neon would be the first noble gas. So we could visualize neon as the core of this, and then we build from there. So essentially, we can visualize 1s2, 2s2, 2p6 as neon. We write it with brackets around it. So the noble gas abbreviation for this exact same problem would be neon, and then we start from there. So for aluminum, we go back to the nearest noble gas. This is element 13, the nearest noble gas is 10. The first preceding noble gas is 10. So it'd be neon, and then this is 3s2, 3p1. You can do this for both electron configurations and orbital diagrams. It's totally perfectly legal. Everybody does this. It makes things so much faster and easier. Okay? So, periodic table. If you can think of it like this, you don't have to memorize that stupid list of how things fill up. So let's try a bunch of random examples and we'll see what happens. Okay, well, and I'll use the periodic table to point out what I'm doing. So, and we'll use noble gas abbreviations for everything. So let's do something like iron. Okay, iron, if you look at it, is element 26. If you count your way back, the previous noble gas is argon. So we start with argon. So it's argon, then 4s2. And then we said the D block, the numbering is off by 1. So this is 3D, 1, 2, 3, 4, 5, 6. Okay, if we wanted to do the orbital diagram for this, it would be the exact same concept. You would draw one box for the S, you write 4s under it, and it would get 2 arrows. Then 3D, the D orbital has 5 orientations. 1, 2, 3, 4. And we have 6 electrons to put in there. Each one of these gets an up arrow before any of them gets a down arrow. So 1, 2, 3, 4, 5, 6. Okay, this is significantly easier than writing 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, 3d6. Okay, we can abbreviate it, so we're going to do that. Please, please do this. Okay. Try a couple more here. Let's say we've got something like tin. Okay, if you look at the periodic table, tin is element 50. If you count your way down, the previous noble gas is krypton, which is element 36. So, krypton, and then we start counting from there. This is krypton 5s2. D block, the numbering is off by 1, so even though this is in the 5th row, this is 4D, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. That line divides it, so that's 4D, 10. 4D10 is where we left off, and then 5P, because for the P block, which is this, the numbering is correct, so 5P, 1, 2. Okay. So, this will be krypton, the 5s gets 1 block, just like usual, has 2 electrons in it. The D block gets 5. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. We expected it to be full, that's fine. P block gets 3. 5p, and this gets 2 electrons. Each box gets 1 up before any of them get 2 down, or before any of them get paired up. Okay. Let's try one more that's a bigger element. Let's do Mercury. Okay, Mercury's got 80 electrons. If you started from the beginning drawing all the boxes and arrows, it's going to take you forever. This still may be a difficult one, but it would take forever if we don't do the abbreviation. So the previous noble gas is xenon. So we have xenon 6s2. And then the entire D block, or sorry, F block fits in before the D block starts. So this is 4F14. And then the numbering here is off by 1, so 5D, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. That D block feels like it sneaks in there, but if you count the numbers, it's like 55, 56, 57, 58, 59, 60. This row clearly is supposed to be in between there. So we haven't violated any rules. As far as drawing the boxes and the arrows, doing the orbital diagram, it's still xenon 6s2. 4F14, this would have, F would have 7 boxes. I'm just 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. Then the D block gets 5 boxes. 1, 2, 3, 4. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So this would be Mercury. So this is still tedious, but this abbreviation thing makes things significantly easier, significantly more straightforward. Okay, it's going to save us a lot of time and effort. Okay, all right, thank you.